right. Well, like you said, my name is Alyssa Manecki. I'm a PhD student at the University of Iowa, and I've been focused on one main question. How can we use new analytical chemistry techniques to identify more emerging contaminants in the environment? So this question has appeared again and again while our lab group has researched at our effluent-dominated stream. So as you can see in the diagram, Muddy Creek, which is on the outskirts of Iowa City, has a single wastewater treatment plant that releases treated municipal sewage. So from past studies, we have determined that there are a lot of contaminants flowing into the creek from the wastewater plant, many more than that are found upstream in the natural water. So we looked for more than 100 chemicals, some pharmaceuticals and some pesticides, and we found especially high concentration of pharmaceuticals like metformin, fexofenadine, carbamazepine, and the neonicotinoid pesticide imidacloprid. So while it's great that we have this comprehensive list of compounds, there are things happening in the stream that we just don't know how to explain. For example, during a fish exposure study where zebrafish were placed in cages in the creek, both upstream and downstream from the wastewater effluent site, the subsequent estrogenic assays of the fish showed that there was actually a greater change in hormone responses of the fish upstream than the fish downstream, which was completely opposite of what we expected. So after parsing through all the chemicals in our list, none of them can explain why we are seeing this unexpected response in the fish. This leads us to explore new environmental chemistry techniques of non-target analysis, which will allow us to more fully characterize the emerging contaminant mixture found in the surface water of the effluent-dominated streams. So before jumping into the untargeted or non-target analysis, let's do a quick refresher on what is targeted analysis. So targeted analysis is the traditional analytical method used for environmental chemistry. If you send your samples to a private lab for analysis, or if your samples must be submitted to a regulatory agency, they will use targeted analysis to get your results back. So for example, if you submit a groundwater sample to check for pesticides, you'll receive back a list of chemical detections from that specific list. But if there's a pesticide present in your groundwater, but it was not included on the lab list, then you'll never know if that pesticide is there or not because you did not actively search for it. Now, in most cases, traditional targeted analysis works great. It's cost efficient, and for most regulatory purposes, you would already have a general idea of what chemicals are going to be of interest. But in effluent-dominated streams, you don't really know all of the inputs. So that's in contrast with untargeted analysis, which is chemistry analysis without the pre-selected list. It's rarely used for environmental samples at this point in time, but we can borrow techniques that have been developed from biochemistry omics approaches. Similar to discovery-based metabolomics, we can use high-resolution mass spectrometry, or HRMS, to effectively scan the entire sample for features. In this case, we are scanning the water of Muddy Creek for emerging contaminants by looking for the accurate masses of molecules. This means that you might find brand new metabolites or other previously unidentified chemicals, but the workflow involves a lot more of the post-processing of the samples before you can confidently identify the compound. So regardless of technique used, both targeted and untargeted analysis are powerful tools to characterize complex environmental mixtures like the water in an effluent-dominated stream. So that brings us back to our study site, Muddy Creek. As you can see in the diagram, the creek flows from left to right and eventually empties into the Iowa River, which is the drinking water source for Iowa City. We've collected samples for both targeted and untargeted analysis at all 4 of the sites circled on the diagram. From the initial targeted analysis, we are seeing pharmaceutical trends that are higher at the effluent, and then they gradually decrease downstream with pretty much no neonics or pesticides found upstream of the wastewater plant.
1 minute.
Okay. Like I mentioned previously, we know that there's fish in the stream and they're being subjected to compounds that can alter their hormones, but we don't know if any of the chemicals are actually making it into their bodies or if it's a surface exposure instead. So native fish and spiders have been collected concurrently with water samples. So as we start getting our untargeted water results back, we hope to connect features found in the water with hormonal effects within the local food chain. In total, untargeted analysis within this effluent-dominated stream will help us to connect the complex mixtures coming from our plumbing to biological effects found in the local wildlife, and maybe even define the exposure mixture found in a drinking water source. Thank you.